Algebra Bootcamp, topic number 4, rational expressions. So these are going to be an extension of our topic 3, which was our rational expressions, but in this case with complex fractions, we were going to have a rational expression in both the numerator and also the denominator. We know that we're going to be completely simplified when we have reduced it all to a single fraction that has one numerator and a single denominator. Let's start with looking at example 1. So in example 1, we have 2 minus 4 over x plus 2 in the numerator, and then 5 plus 10 over x plus 2 in the denominator. I'm going to start by looking at the numerator and finding a common denominator between both terms in order to make it a single fraction. So in this case, if we realize, I'm going to put the x plus 2 together as a factor, and then we can think of that as 2 over 1, and so our common denominator here is just going to be x plus 2. But remember, whatever we multiply the denominator by, we also have to multiply the numerator by. So this gives us 2 times x plus 2 over x plus 2, and then I'm just going to leave that minus 4 over x plus 2 by itself, since it was already had that common denominator. So now, since we have a common denominator, we can go ahead and distribute here on top and then go ahead and combine our numerators. So this will give us 2x plus 2 2x plus 4 minus 4 all over x plus 2. And then we want to do the exact same thing with our denominator. So if we look at the denominator, again, we have a 1 and an x plus 2. So our common denominator here is just going to be x plus 2 again. But if I multiply the denominator, I also need to multiply the numerator. So I get 5 times x plus 2 over x plus 2 plus 10 over x plus 2. If I go ahead and distribute and combine, I'll get 5x plus 10 plus 10, which I can combine to get 20. So now that I have a single fraction in both my numerator and denominator, I'm going to go ahead and add my large fraction bar so I can take care of it. So if we really look at this is really just a fraction being divided by a fraction. Well, we know we can divide by fractions is the same as multiplying by the reciprocal, or we use keep, change, flip. So we're going to keep the first fraction, the one on top, the same, but then we're going to switch it to multiplication and multiply by the reciprocal of the denominator. So this will give us 2x, because I can cross out the 4's, over x plus 2 times x plus 2 over 5x plus 20. If I note there then, the x plus 2's, I have the same on top and bottom, so I can cross those out. And so this leaves me with 2x over 5x plus 20. Now, from here, we might want to go ahead and try to simplify this further. You see an x there, but we cannot cross those out since those are its own factors. So it has to be something that we're multiplying. One thing to also not to forget is our excluded values here, or what values of x would make it 0 in the denominator. In this case, though, we have to remember it can be the denominators of the original, so we have the x plus 2 there, so we can't have x equal to negative 2. But then we also need to take care of our final denominator, which in this case would be a negative 4. So we have 2 excluded values. X cannot be negative 2 and negative 4. And this here is our final answer. In example 2, I'm going to do the same thing. We're going to take care of our numerator first and combine to a single fraction. Now notice here that is 3 different factors of x plus 3 cubed, and then the other one is x plus 3 just to the first. So our overall common denominator here is going to be x plus 3 cubed. And to get that common denominator, I'm going to have to multiply that second fraction on top with another x plus 3 squared. So that will make it a total of x plus 3 cubed. So then I can go ahead and combine, and that will give me 2x plus x plus 3 squared. And I'm going to write that as x plus 3 times x plus 3, so I don't forget to FOIL it here in a sec. Because I need to simplify that numerator as much as possible. So remember, to square means to take it times itself. So if I go ahead and FOIL there, that will give me an x squared plus 6x plus 9. And now I can go ahead and combine like terms. So I'm going to get x squared plus 8x plus 9 on top, all over x plus 3 cubed. Now it is a simplified fraction in the numerator. Could I go ahead and FOIL out the x plus 3 cubed? I can, but you'll see here in a sec why I did not. So I'm going to go ahead and do my denominator, same thing. If we notice here, we already have a common denominator of x plus 3 squared in both. So I'm just going to bring those down, but then I can go ahead, and since I don't have to change any of my numerators, I can go ahead and just multiply, or not multiply, add like terms here. So 5 plus 9 gives me 14 all over x plus 3 squared. And so now I have simplified fractions in both my numerator and my denominator, so I can do keep, change, flip. So I'm going to keep the numerator fraction the same, but then I'm going to change it to multiplication and multiply by the reciprocal of the bottom fraction, or in this case, the x plus 3 squared is now on top with the 14 below. Well, if you look here, this is why I didn't go ahead and FOIL those out. I notice I have 2 x plus 3's on top and 3 in the denominator, so I can cross out the 2 on top, and that's going to leave me with actually just 1 there in the denominator. Let me go ahead and fix that. But I'm going to go ahead and bring over my numerator and bring over my denominator, which in this case is going to be just 14 times the factor x plus 3. Now, in this case, if I could go ahead and try to factor the numerator here, the x squared plus 8x plus 9, if I try to AC method that, I would actually get, in this case, nothing that would actually factor. So there's not going to be anything that can cross out. But if I could, I would want to go ahead and do so. So this right here is going to be my final answer. If I go ahead and do the same thing, I want to go ahead and think about my excluded values. Well, in this case, if I look at my original denominators in both the top and bottom, and then also my final denominator, the only value of x that will make this a denominator will be a -3. So this here will be our final answer.